In a previous video, we looked at what happens when we raise a number to a power that's a fraction, and we looked at raising numbers to fractions like simple fractions like a half and a third. What we're going to do in this video is look at the raising number to a fraction where it's not a 1 in the numerator. So it's not a half or a third, but in this case we've got 9 to the 3 over 2, 9 to the 3 halves. Before we can do that, I just want to quickly recap these two rules that we've shown in previous videos and we're going to use here. So any number a raised to the power of n, all raised to the power of m equals a to the nm, or a to the n times m. We also showed that a raised to the power of 1 over n equals the nth root of a. So if that was a to the power of a half, it would be the square root of a. Okay, so let's use this to tackle something like, to tackle 9 to the power of 3 over 2. Because what we've dealt with before is fractional powers where we only had a 1 in the numerator, what we're going to try and do here is we want our fractional power to have a 1 in that numerator. And in order to do that, we're going to have to use this rule. A to the n, all to the m is equal to a to the nm. And I can therefore rewrite this as 9 to the power of a half all to the power of 3. Why can I do that? Well, I know that 9 to the half all to the power of 3 is the same as 9 to the half times 3, which equals 9 to the 3 over 2. If we bring in our second rule here, while we look at the part of this number in brackets, we've got 9 to the power of half. We know that that is 9 to the power of half. It's the square root of 9, which equals 3. And we're raising 3 to the power of 3. 3 cubed, of course. 3 times 3 equals 27. Let's have a look at another example. Say we've got 8. We're going to raise 8 to the power of 2/3. 8 to the power of 2/3. Again, I want to find a fractional power that has a 1 in the numerator. So I'm going to say 8 to the 1/3. But if I put it to the 1/3, I'm going to, just like I did here, I'm going to have to raise all of that to the power of 2. Why? Because 8 to the 3rd times by 2 is 8 to the power of 1/3 times 2, which is 2/3. Notice here that 8 to the power of 1/3 we know is the cube root. Cube root, we write like this. The cube root of 8. That's the number that we're then going to square. Cube root of 8, well, we know that's 2. 2 times 2 times 2 equals 8. So actually the number in our bracket becomes 2. 2 squared equals 4. So let's have a look at a general case. If we were to start with a to the power of n over m. Again, we're going to separate this power out. We're going to say that that is a to the 1 over m as our power that we're going to raise a to, all to the power of n. We know from here that a to the 1 over m is the mth root of a, all to the power of n. And there's our general case of when we are raising a number to a fractional power.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.